All right. So what we're going to get into now, like I said, this is the birthday banking problem. Now, one thing that we really tried to do with this class is make it quantitative as opposed to qualitative. We've attempted to put as much information in here so that when you're speaking of something, you can do so with authority because you have numbers. And you know that like 3 times 28 is 84, for example, and not something in the 50s. So, what I'm going to present to you is a way of thinking about sustainability, which is part of the name of the course, in a way that maybe you haven't before. So let's do a little thought experiment. And let's say you've got a rich relative who's going to put $1 in the bank for you every minute from the time you're born. $1 per minute. Nice, rich uncle, right? And now you're going to live to be 100 years old, meaning you're going to die on your 100th birthday. Like just as you're popping the champagne and everyone's celebrating, that's the minute that you croak. So you're going to live to be exactly 100 years old. It's not a good long healthy life. Now, so $1 a minute's going in. So you're going to have to figure out when you solve this problem how many dollars you're going to have on the second you die, because you get this buck a minute. Now, there's a little bit of a twist. You're going to live to be 100, but the catch is you're actually going to get to spend some of this money. Now, you can't spend it like the second it's given to you. It's just like it's a trust fund. It's a retirement fund. It's something that's a gift. And eventually you'll be able to take it out, but only in a certain special way. And I'll explain what that is. The way it is that nature, so this is the bank up here. This is sort of society. Now, down here is nature. And we're going to compare the banking problem that I just described to the carbon problem, or the energy problem that I think has been on a lot of people's minds lately. So nature has been putting carbon into the biosphere. Well, for how long? Pretty much, well, if you want to call the beginning of life on Earth forever, okay, forever. It's fairly well known approximately when life started on the planet, and to have and usually when you say life, it's something that's able, and you guys all had high school biology and all that. Life is a system that's able to extract energy from nature, maintain itself, reproduce, etc. But part of the definition of life is that energy flows through it, right? You eat your breakfast in the morning, lunch, dinner, et cetera, et cetera. And then you spend the energy too. You run around, you think, build your bones, all that stuff. So nature has been putting carbon into the biosphere via, well, what does that? What natural process does that?
Breathing.
Well, before breathing, what was there? Yeah, decay is the opposite. Photosynthesis is what we're looking for. And when Mark, we didn't cover too much of that in 101, do we? Now, photosynthesis is more of like a 102 type thing, bioenergy. 101 is mainly about conventional energy, the historical energies that we've used since humans started developing technologies. But photosynthesis, you can think of as that rich uncle that's putting that buck a minute in the bank for you. Okay, so you're going to want to know, first of all, you're going to want to know how many minutes old, and I'll let you get started on this if you want. You're going to want to know how many minutes old a 100-year-old person is. all right? And you're also going to want to know how many years old life is. And I'm not going to tell that to you. You're going to have to kind of remember or look it up on your phone or however. You're going to have to estimate how many years, let's see, so there's 100 years old. I'm just going to put question mark. Now you're going to want to put this in minutes. But the question is, how many years old is life itself? Okay, so those are a little bit of information I've given you. You're going to know how much money you have in the bank. That's going to be like dollars in minutes. It'll be as many dollars as it is minutes. And then we'll see how old life is also. But now we're fairly aware of the fact that the carbon that's been sequestered in the Earth's crust, coal, oil, natural gas, most of it got there through a photosynthetic pathway. That's what life does. It takes CO2 out of the atmosphere, turns into glucose, turns into starch, turns into every single hydrocarbon you ever heard of, and now it's underground in fossil fuels. We're using those fossil fuels now. We are that old person withdrawing from that bank. And so what we'll do now is look at the approximate year. Now, you could say, well, people have been extracting energy from nature for a long time. We were cutting down trees, building campfires, cooking with wood, et cetera, et cetera. But I'm going to make the argument that the I don't know the right word to use here. The aggressive use of fossil fuels started in about 1860. So when was Titusville? I think Titusville was, I'm just going to say about 1860. The exact plus or minus a few years is not going to matter. But 1860, Titusville, Pennsylvania is when oil was really first discovered on a large scale on the North American continent, 1860. And that's, well, how many years ago is that? Rain's like, what the heck, man, this guy can't do math.
155.
Yeah, it's 155. We're going to just call it 150 years ago. 150 years ago. So, 150 years ago. 150 years ago. Now, what you'll also see, Mark's going to go over this whole concept of peak oil. Who has not heard of peak oil? Okay, Mark's going to cover that with you. It's a theory that was developed by a geologist working for Shell Oil in the 1970s, and he was looking at a bell curve. Who's not heard of a bell curve? Okay, everyone knows what a bell curve is. Another word for it is a Gaussian curve or a normal distribution. And typically things in nature follow this thing called a normal distribution. Track score, track times, heights, and if I could draw a little better, that would be exactly symmetric. But it just means that this stuff over here is sort of below average and this stuff over here is above average, and it's a 50-50. And like everyone on whatever scale falls on one side or the other. Same thing happens with the extraction of fossil fuels from the planet. And he kind of looked at, here was 1860, looking at the rate at which fossil fuels were coming out of the ground. Now the technology gets better and we can get it out faster and faster and faster. But then he thought, oh gosh, now it's a little harder to get at that stuff. Why is that? It should last forever, right? Well, no. First law of thermodynamics says that there's a finite amount of matter and energy in the universe and nothing lasts forever. So he started to see this tapering of this curve and thought, well, if I assume that the extraction of fossil fuels follows a pattern that I've seen everywhere else in nature, we're going to hit peak oil about 2010, 2015. And that's about where we are now. And so, from that prediction, you can predict about when it's all going to be gone. And what you'll see in this class in Summary 3 is we'll look at a website called Worldometers, and it tracks these large scale issues. And so I'll let everyone here in the classroom do the math and tell me about when you think it'll be gone. So if we're halfway through, and this is now, and there's 1860, you should be able to tell me about how many years. So I'm just going to put the number of years that this time span is. Okay, so back to the banking problem. Back to the banking problem. This time span right here is your retirement party. That is the time span over which you get to use that money that your uncle put in the bank for you. So what I'm asking for is, how long is your retirement party going to last? How many years, days, minutes, seconds? How long is it that you get to party with that money that your uncle put in the bank for you? All right, any questions before I set you loose on this thing?
Yeah.
Tell me, yeah, Rain, go
I
ahead.
mean, how long do you get to use it for? Like, how much do you spend in a day? What are you allowed?
It doesn't really matter. Well, it's a good question. How much do you get to spend a day? You're going to spend all of it.
Okay.
Because, I mean, on the way we're going, we're going to burn every bit of fossil fuels.
So are we saying that our retirement starts at, like, say, 63 of our 100 years?
It could be 63.
Okay, so
But the problem is, what we're looking at is that, again, this number of years is the length of time over which photosynthesis has been doing its thing, and your rich uncle's been putting money in the bank. Okay, so you got to figure out how long that's been happening. And then you take a look and say, how long is it that humans, our technology, are going to use to extract that? So it's got to be that same ratio. So it's going to come down to a pretty simple formula. And you could, so it doesn't really matter. I mean, you could spend it, instead of in a bell curve fashion, you could spend it in a continuous manner. You could sort of spend it like this if you wanted to, with 10 million bucks a day or $1 million bucks a day, or however many dollars per day it ends up being, or years or whatever. So does that kind of answer your question? You have to look at those two ratios. The ratio of how long nature's been putting that carbon in the bank to how long humans are going to extract it, and tell me how long your retirement party is. Everybody pretty clear on that problem? I see some calculators coming out. I see some, what the heck's going on? I didn't know I was going to have to think on the first day of class.
You
Yeah.
just wanted us to tack on what we've already spent from 1860 to what we're going to continue to spend till the end, until we cash out?
That's a good way of thinking of it. Is that you started spending in 1860, and you're going to be done spending this little question mark, this little question mark deal right here, and you need to, and you're going to know how long that is. So the thing you have to figure out is how many minutes old a 100-year-old person is, how long life has been on the planet, and how long we've been, or how long we will have to go through all those carbon reserves. Okay, so I'm going to pause the recording, give you about 10 minutes. It's like Jeopardy. I'll put the Jeopardy music on, start thinking. But team up a little bit on this if you don't mind. Well, I don't know. I don't know how friendly you guys want to get, but just form teams of 2 if possible. If you guys across the back there want to form a team of 3, team of 3 in the middle, team of 2. Yeah, so just partner with the rows. So we got team 1 front left, team 2. This guy's looking up the answer already. Yeah, or just okay, that's fine. And then yeah, okay.
So every 4 years is an extra day.
All right, so